Hello and welcome to this video on introducing simplifying rational expressions. We're going to be talking about some kind of general notes thing in this video, starting out with the example you see at the top here. So we have a problem that a student or a teacher has completed, where they have on the left side here, we have x minus 5 and x plus 3, both in parentheses on the top. And then we have x plus 2 and x minus 5 on the bottom. So their first step they've done in this work would be to basically cross out the two x minus 5s on the top and then the bottom as well. And they would be dividing those out by dividing by each other and essentially making it equal to 1. Because you figure that x minus 5 divided by itself, well, that is supposed to equal to 1. So now we're at step 2, where you're only left with x plus 3 on the top and left with x plus 2 on the bottom, and that is equal to 3 halves. So I want you to think for a second, well, do you agree with this work, and why or why not? And if you don't agree with this work, what would you change about it? So take a second to think about that. Now, if we want to see if something is true all of the time, that's a little bit harder than proving something false. In order to prove that something's false, you just need one counterexample. To prove something is true, you need to show that it's true all the time. So let's see if we can come up with a counterexample. And to do that, all we need to do is think of a value for x we could try. So let's see if we could do that. So let's say that we made x 4. So let's say that x was equal to 4, and we would be doing 4 plus 3 on the top, and we'd be doing 4 plus 2 on the bottom. And so that would mean that we'd be doing 7 divided by 6. Now, we saw in the first work that the x's are supposed to go away, and the whole thing has to equal 3 halves. But over here, we have a situation where it equals 7 over 6. If you do 7 divided by 6 in a calculator and check that decimal out, you would get an answer of 1.17. So this equals 1.17, but 3 halves, that is actually equal to 1.5. So we've found a counterexample to show that these are not going to be the way to do it. So if we write that last part again, because the first step was fine, dividing out the x minus 5s on the top and the bottom. But if we were looking at just x plus 3 and x plus 2. So when we're trying to simplify fractions in general, you want to see if you can divide out common factors, which we'll talk about a little bit more in this video in a second. But whenever you see on the top and bottom, if things are connected by addition, like x and plus 3, x and plus 2, addition and subtraction, essentially you can think of them as gluing things together, in that you can't just divide those two x's or divide the 3 and the 2 because of the addition that's connecting them. If it was x times 3 or an x times 2 on the bottom, well, then we could do that step that they tried in their work, and it would work. But in this case, this is as simplified as that process can be. Okay, now in the next part of our introductory notes, it says you are familiar with a number of mathematical operations such as addition, subtraction, multiplication, division, and also exponents with their rules. And you may have heard the word canceling or cancellation before. So now this isn't really part of that list. Really, it's just a different way of saying division or dividing. So what I would say to this would be no. Cancellation is just a fancy way of saying dividing. A fancy name for dividing both the numerator and denominator, both the numerator, both the numerator and denominator by the same thing or by the same factor. And you may have seen that happen with lots of fractions before in your math education. And that's basically the definition of canceling, quote unquote, canceling in a fraction. Is basically, we could underline this, dividing both the numerator and denominator by the same factor. And that is what canceling really means. And that's what we could write in the kind of definition part that we have right there, that underlined red portion. Okay, so now if we look kind of lower down here, so when we are looking at fractions or rational algebraic expressions, which we're going to be doing a lot with in this chapter, these can all be simplified by factoring the numerator and denominator and then quote unquote canceling all the common factors. So if you can break down the numerator and denominator into all the factors that you can first, then you'll kind of be able to tell, well, I have some things on the top and on the bottom that are the same. When you have things that are the same on the top and the bottom of a fraction, you can divide them out, essentially dividing them by themselves and getting 1. So you can just remove them, because multiplying by 1 on the top or the bottom isn't going to change anything about your fraction. And so we have an example here to look at first in our last part of this video here. So we have 2470 over 1771. And so we would try to be able to figure out, well, what could divide into these numbers that might help us to simplify it in any way. And that is what our next goal would be in this case. Now, if I want to try to simplify this, we need to find some factors of 2470 and 1771. So let's try to do that first. So if we have our top part, 2470, well, obviously that's divisible by 10. So I would have 247 being multiplied by 10. And then on the bottom, 1771 is divisible by 7. So I would have 253 times 7. So we have one thing. We don't have anything in common quite yet. So for 253, 253 is divisible by 11. So I would have 11 times 23 to get me 253. And then I would have the 7 left over on the bottom still. And then 247 is divisible by 13. So I would have 13 times 19 times 10. So we're coming up with a bunch of prime numbers here, which is something we're looking for sure. The last one would be that 10 I can still break down to 5 and 2. So I have 13 times 19 times 5 times 2 on the top. And then I have 11 times 23 times 7 on the bottom. And now we can see in this example that we have 4 prime numbers on the top and 3 prime numbers on the bottom, but there's nothing I can divide out. There's no factors on the top that are the same as the bottom. And that means that our fraction that we started with was this most simplified that it could be. And so we would know based on this process that we have simplified that kind of large number fraction as much as it goes. And that's something we're going to be applying to expressions where we're going to look at the top and bottom of our rational expression, where we're going to have kind of polynomials on the top and the bottom, and looking at whether we can factor anything at the top and bottom, and then using those factors and the similar ones to divide out and simplify the fractions we're looking at. And that covers some opening notes for simplifying rational expressions. Thank you for watching.